Data centers now consume about 1 to 2% of the world's electricity, and their energy demand is only growing. But what if we could make them far more efficient? Today, we'll dive into the numbers, explore how AI is optimizing energy use, and look at game-changing ideas from liquid cooling to green energy solutions. By the end of this video, you'll see how tech giants and innovators are reshaping the future of data storage. Let's start with the raw numbers. According to the International Energy Agency, data centers worldwide consume about 200 terawatt-hours of electricity annually. That's more than the total energy use of some countries like Argentina or the Netherlands. Now you might wonder, where does all this energy go? About 40% powers the actual computing, the servers processing billions of requests every second. But nearly 35% is spent just on cooling. Traditional air cooling systems work overtime to prevent overheating, especially in massive server farms spanning football field-sized buildings. Cloud computing giants like Google, Microsoft, and Amazon are acutely aware of this challenge. In response, they've developed hyper-efficient systems that minimize waste and improve performance. Google, for example, claims its data centers use 50% less energy than the industry average, thanks to cutting-edge AI-driven energy management. But even with these optimizations, the question remains: can we truly make data centers sustainable? Adding to the complexity, data center energy demand is expected to double by 2030 as AI, cloud storage, and the Internet of Things continue to expand. This means we need more than just incremental improvements. We need a revolution in energy efficiency. To put things into perspective, the carbon footprint of global data centers rivals that of the entire airline industry. And while aviation gets a lot of attention, our digital activities quietly contribute to massive emissions. Let's take Bitcoin mining as an extreme case. The global Bitcoin network alone consumes an estimated 100 terawatt-hours per year, half of what all data centers use combined. But even traditional cloud services contribute heavily. Streaming 10 hours of 4K video a month produces as much CO2 as driving over 100 miles in a gasoline-powered car. So where does this energy come from? Currently, about 60% of the electricity used by data centers worldwide still comes from fossil fuels. However, companies like Microsoft and Amazon are aggressively investing in wind, solar, and even experimental energy sources like hydrogen fuel cells. Microsoft aims for 100% renewable energy by 2025, and even plans to remove more carbon than it emits by 2030. The challenge isn't just about sourcing clean energy, it's about making sure that energy is available 24/7. That's why some data centers are experimenting with energy storage solutions like massive battery arrays and grid balancing systems that use AI to optimize power consumption. Since nearly a third of data center energy goes into cooling, this is a prime area for innovation. Some of the most promising breakthroughs include liquid cooling. Instead of using air, some data centers now submerge components in special cooling liquids, reducing energy consumption by up to 40%. Underwater data centers. Microsoft's Project Natick experimented with submerging entire data centers in the ocean, leveraging cold water for natural cooling. AI-powered cooling. Google has implemented DeepMind AI to predict temperature fluctuations and adjust cooling systems, cutting energy use by 30%. Waste heat recycling. Some facilities are now repurposing excess heat to warm nearby buildings or generate additional electricity. Each of these technologies plays a role in reducing the environmental impact of data centers. If widely adopted, they could save billions of kilowatt-hours annually. The scale of data center energy consumption might seem overwhelming, but change is possible, both at an individual level and through industry-wide shifts. So, what can be done to make digital infrastructure more sustainable? The role of individuals: small changes, big impact. You might not own a data center, but your digital habits directly influence their energy use. Here's how small changes can make a difference. Optimize streaming settings. Video streaming accounts for a significant portion of internet traffic. Lowering your resolution from 4K to 1080p can cut data use by more than 75%, reducing the processing power required in data centers. Manage cloud storage. Every file stored in the cloud, whether emails, photos, or old backups, requires power to be maintained. Regularly deleting unnecessary files helps reduce storage-related energy consumption. Use eco-friendly cloud services. Some major providers like Google and Apple operate on 100% renewable energy. Choosing sustainable services over traditional ones helps drive demand for cleaner infrastructure. Turn off unused devices and apps. Background processes in smartphones, tablets, and computers continuously send and receive data, consuming power. Simply closing unnecessary applications and disabling auto-sync features can help reduce this impact. Spread awareness. Many people don't realize the environmental cost of digital services. Educating friends, family, and colleagues about the energy footprint of cloud computing can encourage more sustainable choices. How the tech industry is responding. Beyond individual actions, major tech companies are under increasing pressure to make data centers greener. Some of the most promising approaches include AI-optimized energy use. Companies like Google and Meta use artificial intelligence to predict server loads and optimize power distribution in real time. This has already led to energy savings of up to 30% in some facilities. Renewable-powered data centers. Tech giants are rapidly shifting towards solar, wind, and hydroelectric power. Microsoft, for example, plans to be 100% carbon negative by 2030, meaning it will remove more carbon than it emits. Modular and edge data centers. Instead of relying on massive centralized facilities, companies are building smaller, localized data centers that reduce the need for long-distance data transmission, cutting down energy use. Waste heat recovery. Some data centers now redirect excess heat to nearby buildings, using it to warm homes and offices rather than letting it dissipate. Government and policy initiatives. Governments and regulatory bodies are also stepping in to ensure sustainable practices. Key developments include efficiency standards. The European Union has introduced new requirements for data centers, including mandatory energy efficiency reporting and renewable energy targets. Carbon offsetting and taxes. Some cities now require data centers to invest in carbon offset programs or use a minimum percentage of renewable energy. Investment in sustainable infrastructure. Governments worldwide are funding research into alternative cooling methods, smart grids, and next-generation energy storage solutions to support the transition to greener computing. The road ahead. The digital world is expanding, and so is its energy demand. But through better awareness, smarter choices, and technological innovation, we have a clear path toward a more sustainable future. Whether you're an individual making small adjustments or a company driving industry-wide changes, every step counts. The digital world is expanding at an unprecedented rate, and so is its energy footprint. But as we've seen today, new technologies, smarter cooling methods, and greener energy sources are paving the way for a more sustainable cloud. The next time you upload a file or binge a series, remember, there's an entire hidden ecosystem working behind the scenes, and its future depends on the choices we make today. Thanks for watching.